Alright, welcome to today's class. In today's class, I'm going to show you how to solve this physics past question. The question is for 2024/2025 academic session. In our last class, I solved the first question. That's part 2. This one is part 3. I solved question 1A. So let me solve question 1B. It says, the frequency n of vibrations of uniform string of length and stressed with force F is given by n equal to P all over 2L square root of F all over M, where P is the number of segments of the vibrating string and M is a constant of the string. What are the dimensions of M? So we are asked, what are the dimensions of M? So here we have solution. So we are given that N is equal to P divided by 2L and then square root of F divided by M. So this is the formula given. And we are asked to find the dimensions of M. Alright, this is a question on dimensional analysis. If you've not watched or learned dimensional analysis before, kindly check the description of this video and you will see a link to our tutorial on dimensional analysis. Alright, take note of this. When performing dimensional analysis on any formula, numbers, constants, and coefficients are generally ignored. Kindly ignore numbers, ignore constants, and ignore coefficients because they are dimensionless. I'll repeat. When performing dimensional analysis, kindly ignore numbers, ignore constants, and ignore coefficients. Alright, so our first task here is to define the terms given. N is called what? N is called the frequency. N is the frequency of the vibration. N is the frequency of the vibration. And then L is the length. L is the length of the vibrating wire. Alright, so what is F? Let's look at F. F is the tension force. You can either say tension or force in the wire. And then M is known as the linear mass density. M is the linear mass density. It is the linear mass density of the wire. So what is P? P is a constant. P is a constant. And remember, we also have 2 there. 2 is a number. Now, remember what I told you. When performing dimensional analysis, kindly ignore the constants and the numbers given. When you see a number in a formula or constant in a formula, and you are asked to find the dimensional analysis or to dimensionally analyze the formula, kindly ignore the constants, the numbers, and the coefficients. So we are going to ignore P and 2. All right, so our next task is to find the dimensions of each parameter. Find the dimensions of each parameter. So what's the first one here? The first parameter here is n. N is measured in what? N is measured in per seconds. N is measured in per seconds or hertz. It's either used per seconds or hertz. But for the sake of this class, we are going to use per seconds. All right, so the next one here is length, L. Length, L. I'll say this again. If you've not learned how to analyze formula using dimensional analysis, kindly check the description of this video and you will see a link to our tutorial on dimensional analysis. So therefore, N is equal to what? Seconds. Second is the unit of time. So we write capital letter T. And then raised to the power negative 1. So this is the dimension of N. The next one is force, F. F is measured in kilogram meter per second square. F is measured in kilogram meter per second square. So F is equal to kilogram is the unit of mass. So we have capital letter M. Meter is the unit of length. So we have capital letter L. Seconds is the unit of time. So we have capital letter T. And then raised to the power negative 2. So this is the dimension of F, force. So what's the next one? Let's check. We have here L, which is the length. Length is equal to capital letter L. The dimension of length is capital letter L. Since we are done, let's now substitute all the dimensions into the formula given in the question. Now remember that N is equal to P all over 2L and then square root of F all over M. And we are asked to find the dimension of M. We are asked to find the dimension of M. Remember what I told you earlier. We are going to ignore the constants P and the number. So ignore P and 2. Because dimensional analysis has nothing to do with constants, coefficients, and numbers. So n becomes, so here we have 1 all over L and then square root of F all over M. So our next task is to cross multiply. So if we cross multiply, we would have n multiplied by L is equal to square root of F all over M. Alright, so since we have this, we need to eliminate this square root. So how do we eliminate the square root? By simply squaring both sides. So square root of F all over M raised to power 2. And then n multiplied by L all raised to power 2. So therefore, the power cancels off the square root. So here we have n multiplied by L all raised to power 2 equal to F all over M. Alright, let's cross multiply again since we are looking for the dimension of M. Let's cross multiply. So we have M multiply NL raised to power 2 equal to F. So to make M the subject formula, you simply divide by the coefficient of M. So we divide by NL raised to power what? 2. And then here we divide by NL raised to power what? 2. Let me erase this and move it to the center. So we have F. So this cancels off this. So therefore, M is equal to F divided by NL all raised to power what? 2. So this can be written as M equal to F divided by, so it can be written as this, N raised to power 2 multiplied by L raised to power 2, according to the law of indices. If you have not watched our video on indices, kindly check the description of this video. You will also see our tutorial video on indices. Alright, so at this point, we are going to substitute dimensions. We are going to substitute the dimension of F, the dimension of N, and the dimension of L. So it is equal to, what's the dimension of F? Let's check. The dimension of F is equal to MLT raised to power negative 2. So we have capital letter M, capital letter L, and capital letter T raised to power negative 2 divided by what's the next one here? We have Ln raised to power 2. So what's the dimension of N? The dimension of N is T raised to power negative 1. So we have here T raised to power what? Negative 1. And then remember that N is raised to power 2 here. So we write raised to power 2. So the next one here, is L raised to power 2. So what's the dimension of L? L is length. The dimension of L is capital letter L. And L is raised to power 2. So we write L raised to power 2. Alright, so therefore, M is equal to capital letter M, capital letter L, capital letter T raised to power negative 2 all over T raised to power negative 2 and then L raised to power 2. So at this point, T raised to power negative 2 cancels off T raised to power negative 2. And then L here cancels one of the L. So therefore, M is equal to M, capital letter M all over capital letter L. This can be written as M L raised to power negative 1. Alright, so let's check the question. Alright, so this is the question. It says, what are the dimensions of M? The dimension of M. The dimension of M is equal to ML raised to power negative 1. So this is our final answer. Mind you, if you've not subscribed to this channel, kindly subscribe now. And also ensure you like this video. Please like the video. If you have a question, feel free to leave your question in the comment section of this video and I will answer you.